So it's not just the swash and the backwash that dominate the beach. As it turns out, as we said, the waveforms don't become exactly parallel to the beach as they approach. They have an angle. So the swash actually goes up at an angle, and the gravitational backwash is at an angle. So if you have a nice long beach, you end up essentially building a pressure gradient depending on the direction of the waves. And you can see this nice figure here where the waves are actually at a slight angle to the beach face, and you can see that these waves, the foam here has this kind of triangular shape as if there are water flows happening all along these breaks that you see. Okay, so why does that happen? Basically, when you build a pressure gradient like this, little currents keep forming. Sometimes those currents can get very strong, as we will see a little bit later on. So the zigzag movement, later on we will see it in the animation more clearly. If you can imagine now, it's good. Swash going at an angle, backwash coming down, swash going at an angle, backwash coming down by gravity, and so on. So you get this zigzag movement of water along the shore, and you end up setting up longshore currents that can be pretty fast, 4 kilometers per hour. Why does it matter? Because if you're a swimmer, you don't want to swim against a current that's more than about 2 kilometers per hour, because even if you're a professional swimmer, you're going to get tired if you keep swimming against the current that's that strong. Okay, so also because these strong currents keep carrying the sand. Remember, we said the beach is a constant flux of material. The material is always moving around, and these are the kind of currents that do that. So the longshore transport, or the beach drift, or the littoral drift. Littoral is the term for shoreline processes that we won't define exactly at this point. So you can see here swash going up, water soaking in, gravity pulling it down straight. So you have this zigzag movement. You end up building this longshore pressure gradient. So here is the up coast, here are the waves approaching, trying to get parallel. So obviously much more angle here than here. So square root GD, and the shallow water wave is working. And these longshore currents end up transporting sand grains in the beach drift, or the longshore transport. Okay, so millions of tons of sediments are moved every year. Millions of tons. That's a lot of sediment being moved around by these tiny longshore currents. In fact, if you stand in the shallow water, you can actually feel the movement of the sand, right? Before, we had talked about standing in the water and feeling the circular motion of a shallow water wave that is elliptical near the surface, gets flattened and becomes flat on the ground. And here we are talking about transport across. Okay, so the direction of transport can change because of the way the waves may approach seasonally, and net sediment movement is going to depend on the direction of the predominant longshore currents. As we will see a little bit later on, US, which is such a big continent, has 2 long coasts, many degrees of latitude. Both of them have southward coastal longshore drifts. So both coasts have southward transport, and here we are seeing the impact of one of the currents coming in. So if you have these longshore currents being set up, sometimes the pressure gradient can get so strong and the buildup of water and sediments can be so heavy that it ends up creating a current going straight out into the ocean perpendicular to the beach face. Okay, you probably heard this terminology before. It's called the rip current. We'll see a bit more about it later on. So this is just a silly cartoon where the mother is getting a nice suntan here on the beach with the umbrella, and the child is playing around on a tube, and it gets caught in this rip currents and gets taken way off. So every year, many people die, even professional swimmers, if they don't know how to deal with rip current, because if you try to come inland and you are facing a rip current, you may get tired and drown. The trick, of course, is to swim parallel to the coast or across the rip current, get out of the rip current, and then swim in. Okay? So the longshore currents can also end up taking you very far from where you got into the water without you realizing it, that you are drifting. But the rip currents can create serious problems. Okay? So there are many places where rip currents are very normal, and you will see signs at the beaches saying rip currents, be careful, and the lifeguards are always there to rescue, but you can't always take a chance on that, right? Unless you're a really good swimmer. So even if you're a good swimmer, if you hit a rip current and you think you are not being allowed to go forward, then change the direction parallel to the coast and get out of it.